Good morning, students. So we are discussing with black body radiation and a few terms related to this black body radiation. So first of all, as you know, a black body is a body that absorbs all the radiations falling on it. Okay, so black body means a body which absorbs all the radiations falling on it. Then what is black body radiation? The radiation emitted by a black body. The radiation emitted by a black body is known as black body radiation. And also we have studied absorptive and emissive powers. Absorptive and emissive powers we have studied in the last class, and also emissivity. Emissivity means what? As it is the ratio of the emissive power of a body, which can be represented as small e, divided by the emissive power of a perfect black body, which can be represented by capital E. Okay, so this is known as emissivity. So a few terms we have already discussed. Now today we are moving to a law relating this black body, that is Stefan Boltzmann law. Stefan Boltzmann law. Okay. So this law states that the total energy emitted per second by a unit area of a perfect black body is proportional to the fourth power of its absolute temperature. Okay, so this is a law which explains a black body. So in this law it is stated that, look here, the total energy emitted per second by a unit area of a perfect black body. Okay, so when you consider a perfect black body, the total energy emitted by this black body per second, that means in a particular interval of time, by a unit area of it, it is proportional to the fourth power of its absolute temperature. That means it depends, this energy depends upon the temperature. Okay, so if temperature is taken as T and the total energy is taken as E, you can write this statement in the mathematical form as E proportional to T raised to 4. E proportional to T raised to 4, which means that the energy emitted per second by a unit area of a perfect black body, it is proportional to the fourth power of the temperature. Clear? This law is known as Stefan Boltzmann law. This proportionality symbol you can change by multiplying with a constant, that is sigma T raised to 4. Sigma T raised to 4, and this sigma is known as Stefan Boltzmann constant. Okay, and what is the value? Value is 5.67 into 10 raised to minus 8. Okay, 5.67 into 10 raised to minus 8. That is the value for the Stefan Boltzmann constant. Okay, so that's all about Stefan Boltzmann law. Clear? Now we will move to the second law, again another important law, that is Wien's displacement law. Wien's displacement law. So this law states that the wavelength corresponding to which the energy emitted by a black body is maximum and it is inversely proportional to its absolute temperature. Understood? That means if there is a particular amount of energy emitted by a black body, means it has a particular value for wavelength, right? So this wavelength, it is maximum and it is inversely proportional to its temperature. So as temperature increases, the wavelength decreases. So inversely proportional to wavelength, inversely proportional to the temperature. That was given by Wien's displacement law. So I will write the statement here, that is the wavelength corresponding to which the energy emitted by a black body is maximum and is inversely proportional to its absolute temperature. So we can write it as lambda m is proportional to 1 by T. Lambda is inversely proportional to T, and this proportionality sign can be changed by a constant, that is B by T. So lambda m is equal to B by T, and this T is called the Wien's constant. Okay, this B is called the Wien's constant and it has the value 2.9 into 10 raised to minus 3 meter Kelvin. Understood? So this is the unit for Wien's constant. Clear? So in the first case, Stefan-Boltzmann law, it actually gives the relationship between energy and temperature, and in the second case, it gives the relationship between wavelength and temperature. Clear? Now we are moving to another law which is very important, that is Newton's law of cooling. So in Newton's law of cooling, it actually states that the rate of cooling of a body is directly proportional to the temperature difference between the body and the surroundings. Provided the temperature difference is small. Okay, provided the temperature difference is small. So what does this mean? So we have seen that if there are two bodies like this, okay, one is kept at a temperature of 50 degrees Celsius and another at 20 degrees Celsius. So this is the hot body and this is the cold body. So heat will get transferred from hot body to cold body. Okay, transfer of heat or transfer of energy because of the temperature difference of the two bodies. So this body starts to cool, right? As the temperature is as there is a temperature difference and because of the transfer of heat, what will happen? This body starts to cool. So the rate of cooling of this body, it is directly proportional to the temperature difference between the body and the surroundings. Okay, this is the case where we are taking two bodies. Okay, suppose if a body is like this and it is kept somewhere, what will happen? After some time it starts to cool, isn't it? That means its temperature will get reduced. There is transfer of energy from this body to the surroundings. So here also you can say that the rate of cooling of a body, it is directly proportional to the temperature difference. That means if the temperature difference is very small between the body and the surroundings, if the temperature difference is very small, the rate of cooling is also small. Understood? So you can say that the rate of loss of heat is directly proportional to the temperature difference between the body and the surroundings. Understood? So rate of loss of heat is directly proportional to temperature difference between the body and the surroundings. This is called Newton's law of cooling. If you are writing it in the form of a mathematical way, you can write this as dq by dt, that is heat and time, rate of loss of heat. Since it is loss, you can put a negative sign here which indicates that decreasing. Okay, and it is directly proportional to the temperature difference, and let it be T and T naught. So T minus T naught. dq by dt is proportional to T minus T naught, or you can write minus dq by dt is equal to K into T minus T naught. Understood? Minus dq by dt is equal to K into T minus T naught. So this is Newton's law of cooling. Clear for you? So we have studied three laws: Stefan's Boltzmann law, second one is Wien's displacement law, and the third one is Newton's law of cooling. Okay? So now we are going to discuss an anomalous behavior of water. So what does this mean? Anomalous means what? As unusual behavior, something different from the usual behavior. So what is that behavior, and is there any advantage or is there any use for this particular behavior? That is what we are discussing here. So first of all, you know that we have studied that solids, when heated, they will start to expand, and when cooled they will start to contract, isn't it? Likewise, in the case of water also, the water will expand when it is heated and water will contract when it is cooled. Understood? But there is a change for this behavior, that is the expansion while heating and contraction while cooling. This behavior has a change in a particular range of temperature. That means from 0 degrees Celsius to 4 degrees Celsius. 0 degrees Celsius to 4 degrees Celsius. If I am heating the water from 0 degrees Celsius to 4 degrees Celsius, instead of expanding, it will start to contract. Understood? So this is the anomalous behavior shown by water. So water shows an anomalous behavior, that is, it contracts on heating between the temperatures 0 degrees Celsius to 4 degrees Celsius. Understood? Now, when water is cooled below the room temperature, the volume of given amount of water decreases. We know that. So when water is cooled below the room temperature, what will happen to volume of the given amount of water will decrease. So until its temperature reaches to 4 degrees Celsius and below 4 degrees Celsius, the volume increases. Until its temperature reaches to 4 degrees Celsius and below 4 degrees Celsius, the volume increases. Okay, that means the density, volume increases means what? Mass by volume is density. So as volume increases in this particular value, the density decreases. Okay, so it is clear that the water has maximum density. Water has maximum density at what temperature? Is at 4 degrees Celsius. That means at 4 degrees Celsius, in this particular value, it has the minimum volume. Clear for you? So as the water is heated between the temperatures 0 degrees Celsius to 4 degrees Celsius, instead of expansion, they will start to contract. Okay. Then when water is cooled below the room temperature, the volume of given amount of water decreases. Until its temperature reaches to 4 degrees Celsius and below 4 degrees Celsius, the volume increases, which means the density decreases. Okay, so it is clear that the water has maximum density at 4 degrees Celsius. That's a good question. Water has maximum density at 4 degrees Celsius. Clear? Now, actually this particular behavior is an advantage in the case of the marine animals. That means, for example, lake. Okay. So the marine animals like fishes and all will be in this particular lake or pond, whatever it is. And in this case, as you know, the lake in colder regions, the lake cools towards 4 degrees Celsius. Towards 4 degrees Celsius, water near the surface loses energy to the atmosphere. They become denser and they sink. Okay, so the warmer, less dense water near the bottom rises. However, when the temperature reaches below 4 degrees Celsius, what will happen? It becomes less dense. Okay, so less dense, and it will remain at the surface itself where it gets freeze. And because of that, here the marine animals could survive. They can remain alive and move freely near the bottom. Understood? So, in a lake towards 4 degrees Celsius, water near the surface loses energy to the atmosphere. They becomes denser and they sink to the bottom. Again, the warmer, less dense water near the bottom rises. This is what actually happening. But when it reaches a temperature below 4 degrees Celsius, as I told, below 4 degrees Celsius means 4 degrees Celsius getting reduced to 0 degrees Celsius. Okay, cooling towards 0 degrees Celsius, what will happen? Instead of contraction, it will expand. Okay, if it is heated from 0 to 4 degrees Celsius, instead of expansion, it will contract. So here it is expanding. Okay, so as a result, the volume increases and density decreases. So less density, which means that it will remain at the surface where it freezes. This phenomenon allows the marine animals to remain alive and move freely near the bottom. Clear for you? So that's all about anomalous behavior. So this is also an important question. Okay, study it just an application of the anomalous behavior of water is the survival of marine animals in colder regions. They can move freely, they can remain alive in the at the bottom of the lake. Why? Because when the temperature decreases below 4 degrees Celsius, it becomes less dense and it remains at the surface where it gets freeze. Okay, where it freezes. And this will allow the marine animals to move freely and remain alive near the bottom. Okay. So we have come to the end of this chapter, that is thermal properties of matter. In the next class we'll move to the next lesson, that is thermodynamics. Okay, so have a nice day. Thanks.